Today we're going to talk about how to count atoms in a chemical formula. So let's remember what a chemical formula is. So a chemical formula is what is used to identify the elements and number of atoms that are present within an element or a compound. So it identifies elements and atoms, or number of atoms. All right, so we're going to start with this kind of simple when we start counting atoms. We're just going to do a very simple, here is an element. So let's start with oxygen. Let's say you are given this chemical formula, just the very simple O. Remember we talked about last week how when we write a chemical symbol, that a chemical symbol is written with a capital letter, and it's a lot of times just a single letter. Sometimes a lowercase letter will follow it. When you see that lowercase letter, you know that it follows the capital letter that is immediately in front of it. If you cannot identify that element on its own, then that's when you can go refer to the periodic table. So O is oxygen. So we're going to go down. We've identified that this is oxygen, and we're going to write it down. So first step is to identify the symbol. What element is that symbol representing? So like I said, this is your symbol. We know that O is oxygen. And then you're going to find out, well, how many oxygen atoms do we have present? Anytime you have a single element listed with no numbers that follow it, no numbers that precede it, then that means there is an understood one atom of that element. So when you see the chemical formula O by itself, nothing else, then we have one oxygen atom. Okay, so let's take it up a notch. Let's say we get H2O. Most of you are familiar with this chemical formula, and we know that that is water. Okay, so what you're going to do first when you start counting atoms is identify your chemical symbols. Identify the elements that are present. So if we look at this example, we have H, and then we have O. So we have two different elements, so let's write down those element names. First is hydrogen, and the second is oxygen. And then you're going to try to figure out how much of each. So if we look at hydrogen, hydrogen has that subscript, that number 2 that follows it. Anytime you say a subscript, remember subscript is that small number, then that subscript is referring to the immediate symbol in front of it. So that 2 does not apply to the O, that 2 only applies to the H. So that means that we have 2 hydrogen atoms. And then we go to oxygen. If we look at oxygen, oxygen does not have a subscript. Oxygen does not have a coefficient out front. So oxygen, we understand when there is no subscript, no coefficient present, that there is 1. Now, you may also be asked, well, what are the total number of atoms in H2O? And then all you have to do to calculate that is add. You can all do that. So 2 plus 1 is 3. So we have 3 total atoms in H2O. All right, let's get a little bit more complicated. Let's try one that has multiple subscripts, okay? So let's say we have lithium sulfate, which is Li2SO. Oops, let me erase that 4. I want that to be a subscript. SO4, okay? So first things, let's go through and identify each chemical symbol. So we have Li, we have S, and then we have O. Now, we know that the S and O are separate is because they are their own capital letters. Capital letters give us where our new chemical symbol begins. So then let's go through and write down what each of these elements are. I know what Li stands for. If you do not, you would want to go look at a periodic table to identify what element this is. Li is lithium. S is sulfur. And then we've already said O is oxygen. Now let's go count our atoms. So in this chemical formula, we do have 2 subscripts. A subscript follows the symbol that is immediately in front of it. So this 2 applies to Li, this 4 applies to the O. So that means we have 2 lithium atoms. Let's look at sulfur. Sulfur does not have a subscript. Sulfur does not have a coefficient nearby, so then that means there's an understood 1 atom of sulfur, and then we have a 4 subscript for the oxygen, so we have 4 atoms of oxygen. And then same thing here, if we want to know total number, we're just going to add that up. 2 plus 1 is 3, 3 plus 4 is 7 atoms total. All right, now let's do an example with a coefficient. So let's use H2O again, but let's say we have 3 H2O. Once again, let's identify our chemical symbols. We have H, we have O. We know that H is hydrogen. We know that O is oxygen. So now let's figure out how many. The thing about this chemical formula is we have this 3 out front. That's our coefficient. Okay? When you have a coefficient, that coefficient is telling us that we have 3 water molecules. So we have 3 H2Os. So then all we have to do for this type of situation is distribute that 3 to everything within that chemical formula. So we're going to say we have 3 H2s and we have 3 O's. So if we have 3 H2s, that means we already had 2 hydrogens. Now we're going to have 3 sets of 2 hydrogens. So you're going to say 3 times 2, and that is going to be 6. And then you're going to do 3 times O. There's no subscript, so that's understood 1. 3 times 1 is 3. Now, the other way you can look at this just means we have H2O, H2O, and H2O. Okay, so there's 2, 4, 6, 1, 2, 3. So if it's a little bit easier for you to look at it that way, that might kind of make sense. So there's 6 H's and 3 O's, which is what we figured out here. But if you need to look at it and set that up that way, you can. All right, so that means we have a total of 6 plus 3 is 9 atoms.